Jason, Fred, Shuming, and Rami. Hello, everybody.
Hello,
Yep, just
Abby.
a reminder and to drop your questions in the chat.
So we have, this is Fred. I'm the Director of Sales for Graphical Networks. Adriana, most people who are NetTerrain customers probably know Adriana. She's the account manager for the US region. So we have an hour for today's webinar. Just want to thank you for your time. As Audrey mentioned, there is a Q&A button and a chat button. Feel free to chat with us, ask questions. We'll go through those questions through the end and during our, our webinar. So that's it. I'll pass it off to Jason. Jason heads up our customer support, sales engineering department at Graphical Networks.
Yep.
And then AMI, who you saw in the title. So they have a product called DCM. So that's what we're going to talk about today, which is really what we call the netTerrain EM module. Shuming and Rami, we've known them for years. So we're going to talk a little bit more about the EM module, which is, I know I'm going through some of the slides like we're supposed to go through already, sorry. It is a add-on module to our netTerrain DCIM product, but I'll stop my talking and I'll pass it off to Jason.
Yeah, hi everybody. It's Jason Sherman. I'm sure I've worked with some of you if you're certainly a customer in the past. So as was mentioned, we'll be really exploring the EM in a bit more detail and what it can do. Just to get started, these are the folks that are on the call today, myself and Fred at Graphical Networks, and then Shumeng and Rami. And I'll let them introduce themselves when the time comes, when they're, set to speak. They can talk about kind of their role and what they do at AMI. So moving on the agenda for today, basically we've got the polling question. Someone's going to launch here in a second. We'll do a quick overview. I'll just talk about netTerrain. That's our product. And a lot of you might know that. I'm not going to spend much time on that. It's just a quick slide. I'll get back into more of a live demo of netTerrain here in just a little bit. Polling question 2. So we'll fire off a couple polling questions and then get into the main discussion. We'll kick it off with polling question number 1. If somebody wants to launch that, it'd be great. I think the last time I tried to launch polling questions, it went terribly wrong. So I'm not going to touch that. How do you currently track power usage and costs across your infrastructure? So manually, of course, Excel and things like that, various other tools, a DCIM solution. We don't, or, looking for a solution currently if you're, maybe in one of those two camps. Feel free to check mark one of those. I guess you could choose more than one. And then we will move on basically to the next one. But give you guys a second to do that, and then we'll close that out. While that's, that polling question.
Okay, I closed that one out.
What were the results there, by the way?
Sure. Most folks are using not surprisingly manual methods. Excel, hodgepodge of various tools. 11% are currently using a solution like netTerrain or maybe netTerrain. Hi to our users. And then we've got 33% that just really aren't tracking.
Sure.
Which we're quite used
Makes
to.
sense.
Yep.
Okay. Yeah.
And then
Good stuff.
thank you.
Thanks, Anna. So netTerrain, that's the product Graphical Networks makes, manufactures, and sells. And of course, we're going to talk about the EM module that you can get and I'll talk about how they kind of work together, or we all will to a certain extent. But netTerrain's really automated it's a documentation tool. There can be automation. But you can do a lot of hierarchy. It's really to kind of reflect an as-built network environment. So network documentation that could consist of different things: DCIM, outside plant, EM, etc. So we'll get back to that in more of a live demo. But polling question number 2, and then we're going to jump into some conversation with AMI folks. What's your biggest challenge making your data center more sustainable? Tracking energy usage, lack of visibility in infrastructure, budget constraints. That's probably number one. Complexity of tools, and not sure yet. It'll be interesting to hear what the results are here as well.
Also, just briefly wanted to point out that in the chat, we do have a lot of links and resources posted there for you to check out.
And we'll definitely be checking the chat and questions and stuff here as we go along. Or some of those we might table to the end, but anyway, question two, give it a few more seconds here. And we'll close that out, share some results.
Okay, I closed it. I'm gonna hit the share results button.
Oh, cool. All right, tracking energy, lack of visibility, budget constraints. Number one, figured that might be it. Complexity of tools, not sure yet. It's good stuff. Thank you for that. So moving on, first person, we're gonna go with Shuming at AMI. He's gonna speak to you guys about obviously kind of an introduction to the AMI data center manager. Anyway, Shuming, if you're there, I'll let you take it away, and I can fast forward the slides when you're ready.
Okay. Thank you.
Thank you.
Thank you, Jason. My name is Shuming. I'm a solution architect from AMI, and I'm based in Toronto, Canada. And I worked at Lenovo, GE Healthcare, and Intel before. So I engaged in the data center for more than 20 years. So let me introduce some challenge we are facing. And next page, please, Jason. So here we talk about the first challenge we are facing. This is the electric demand increase sharply in data center. It's reasonable, from before the ChatGPT, one Google search consume about 0.3 watt hour, and after ChatGPT, one ChatGPT request consume 2.9 watt hour, almost 10 times of the generic search. So that's the reason. Next page, please, Jason. So let's look at the main part of the data center, XPU. Here, XPU stands for GPU, CPU, IPU, DPU, etc. So you can see here for the GPU and CPU, the TDP, thermal design power, tripled in the past 10 years. For GPU, right, from 300 to 1,000, right now it's 1,200. CPU, 165 to 500. So tripled in 10 years. Next page, please, Jason. So let's look at another challenge we are facing. That's the power density per rack. On the left, you can see it's a generic computing rack. The power density per rack increased rapidly. But on the right, especially for the AI and HPC, it's super high. It's 80 to 100 kilowatt per rack. So it brings a lot of challenge. For example, PDU, UPS, cable, thermal, cooling, and the leakage, etc. Right? And next page, please. So let's break down the energy consumption for the data center. Here, IT equipment versus the infrastructure. IT equipment consume 62% of total energy, while infrastructure consume 38% of total energy. So from here, we can easily calculate the PUE is around 1.6. So we still have its average worldwide level in 2024. So still a big room to improve. And let's look at from the carbon footprint. 10% of the carbon footprint of data center come from embodied carbon footprint, while 90% of the carbon footprint from operation, data center operation. So data center operation energy efficiency is very important. How to improve the data center operation energy efficiency? Let me hand over to Remy. Remy, please.
All right. Thank you, Shuming, and thank you, Graphical Networks, for having us. It's really a pleasure being with you here today, and we've been really excited to be partnering with you over the years. I'm a product manager at AMI. I'm responsible for the Data Center Manager product, its features, and its roadmap, and of course, working with partners such as yourselves to get your feedback and requirements and integrate that as part of our roadmap moving forward. So I thought of kind of very quickly talking about what the environmental monitoring EM module is in netTerrain. It's essentially a module that uses standard protocols like Redfish, IPMI, SNMP, and SSH to gather more detailed telemetry, out-of-band telemetry from all the IT devices that you typically find in a data center. So obviously, there's a lot of focus historically on the product on the server side of things, but because that's what the main commodity in the data center is. But we've also supported over the years a bunch of different types of devices, including power, storage, networking, and cooling, as you see here in the diagram. All that data is collected, analyzed, aggregated and stored into the EM module, and then exposed to the end user through the web interface for the user to consume in different use cases. And one of the strengths of this module is being able to not just keep, give you a granular view of the data of those IT devices in terms of their power consumption, inventory, health, utilization, but also to aggregate that so that you can get views all the way from the device level to the rack level and eventually to the data center level. So that's one of the strengths of the product, and especially as we saw in the poll, there's a big need today to understand how the individual devices work on that granular level to be able to manage their health, make decisions for their growth, and also manage their sustainability and carbon emissions. So going a little bit deeper into some of the use cases that this product kind of provides, not only are you able to support various devices, but we are vendor agnostic, so we support different devices and different models and generations of each device. For example, for PDUs, you will have the same interface regardless of the type of PDU, eliminating the need for you to use proprietary software from the PDU vendor. So you're able to do things like manage the PDU outlets, power on and power off, and so on. And if you go to the next page, you'll be able to see that for each PDU, you can see the different sensors, including their temperature, current, voltage, humidity, if that's supported. And again, that interface is very consistent across the different types of devices. Moreover, you can see, like shown at the bottom there, the trending graphs for power and temperature for over a period of time. And you can also see the health of the subcomponents of that particular device. In this case, there's some faults that have been identified, and you can also see the history of those faults over time. And you can, of course, subscribe to the different events so that the right personnel get the correct notifications and take action accordingly before those issues become more catastrophic. And then if we go to the next page, we can look at what this means on a server level. So with the need, especially with the advances of AI and so on, there's a need to manage devices and components on a more granular level, ensure that they are performing optimally. So with EM, you're able to manage the power consumption, carbon emissions on a device level in real time. And you're able to see things like the utilization metrics for GPUs, for example, and also for servers. And that could help you identify, like in this case, times when the GPUs are not efficiently utilized. As you can see here, there's significant spikes and dips, which means that you might want to take action to make some adjustments to your workloads or scheduling to more efficiently utilize those resources. And of course, one of the last things here I wanted to mention is the ability to perform power policies and perform power caps, whether it's as an insurance policy so that on the rack level you don't exceed a certain limit, or as a way to control your energy consumption and also increase your rack densities, which can help with space management and save that way. So yeah, if moving forward, another interesting use case is being able to identify underutilized servers. This sounds a little bit too simple, but there were studies even as late as the second half of last year, which have shown that there could be up to 20 or even 30% of underutilized servers in any particular data center, especially the ones that are not running GPU workloads consistently. So DCM is able, without any additional agents that have to be run on the system, is able to detect those and is able to tell you how much power they're consuming, even though they're idle and not running any work, and how much carbon emissions you would save if you either shut down or consolidate those systems accordingly. And you can also, as you see here on the right, you can create power characteristics for different server models. And from there, you can identify which servers are running more than others and make some decisions that way. And as you can see here at the bottom, turning off such servers or ghost systems or servers as we call them can rack up significant savings over a period of time. So in this case, just finding, I think, certain small percentage of underutilized servers, shutting those down can lead to almost $25,000 savings per year. Another thing you can do is compare servers against each other, and also, like I was mentioning before, compare how the server models that you have in your infrastructure are performing, which ones are consuming more power than the others. That can help with some server procurement decision making and help you compare server generations and even architectures against each other, as you can see in the lower graph here. In this case, you're running 3 different servers, assuming that they're running the same workload. You can easily identify which ones are running more efficiently relative to the others. This, of course, does not take performance into consideration, but you would have to correlate that information and make the most informed decision on whether you would go with one architecture or one server model or one specification versus another. And another, use case that comes out of this is being able to perform what we call server what-if analysis. So for server consolidation, we talked about that recently, but we can go a step forward and say and see and model, if we take down these servers, how much power savings and energy savings we can make in over the next 3 months, and how much carbon emissions that would provide. So that shows you the graph on the left side there, and shows you the change that would be affected by that reduction in underutilized servers. Of course, here it's showing, graphically it's not so visible, but value-wise, it's 7 megawatts over the next 3 months. So of course, you can imagine as your environment gets bigger, this can, be more meaningful. And going to that other use case on the right, server replacement analysis, you can easily use the historical power consumption that DCM collects over time and stores over time for different server models to make decisions on how that will impact and basically model the change on power consumption and carbon emissions as well. So in this case, you're replacing several older, I think, if I can see correctly here, 50 of those older Dell servers that have been running at 360 watts on average, with a newer generation that is running at around 189 watts. Assuming that they're running the same workloads, then that's a significant improvement in your power consumption and carbon emissions. So you're probably improving your compute because this is a newer generation server, but you're also reducing your carbon emissions. So again, another great tool for server procurement decision making. And, of course, you can't talk about data center management without talking about cooling analysis. So one thing that EM provides is being able to create like a histogram, like you see here on the left, showing the different temperatures of all the devices in a particular room with respect to a certain ASHRAE criteria. So in this case, you can easily identify rooms that are unnecessarily overcooled. Like in this case, most of the servers or the devices here are running colder than you'd expect. I think that's 14 degrees Celsius. And we see this a lot. Data centers overcool just as an insurance policy unnecessarily. And we've done studies on how 1 or 2 degrees increase in the set point temperature can safely save you significant amounts of cooling costs. And then also this cooling analysis has a good, side effect of being able to identify hotspots like that device or those few devices on the right there that are running hotter than anything else. In this case, if you correlate that to this front view of the racks, you can identify that even though this particular rack is being cooled by this cooling unit, it's running hotter than the rest. So if you double click on that, so you know that it's not it's a health issue, essentially, not a cooling issue. So, and if you double click on that, you can identify that it becomes, you can see that, for example, there's a leak in the liquid cooling piping, for example, to that particular server.
Yeah.
So,
I had a question for you, Rami. Sorry to interrupt.
Yeah, sure. Absolutely, Jason.
The cooling criteria that you have up there, you have different, I guess, criteria you can pick from. Are those different standards from different sort of organizations or groups that you can compare to?
Correct. I think there's 2 or 3 ASHRAE criteria. So the list is not long in that combo box. Mm-hmm.
Gotcha. I was just looking at that and just figured I'd ask you since I had you on the call. But
Yeah, sure. Absolutely. Feel free to do so.
Pretty cool. Anyway, let's continue on. Sorry.
No problem. Thank you, Jason. Okay, so then, like I was saying, the strength of EM is you're taking a deep, granular look at the device level, but then you're using that to create a holistic view of your data center. So in this case, you're able to see the total, monthly and annual, actual and projected carbon emissions, and you can set thresholds on both the monthly and actual timeframes, and you can set the module to send you alerts as you get closer to those thresholds or as you exceed them, so you can make decisions accordingly and help you reach your sustainability goals. And then that translates into performing things like reducing your cooling costs or reducing your specific energy consumption per device by applying power policies and so on. can go to the next slide. So one thing that's worth mentioning here, and these are relatively newer features we've added, is the ability to calculate the real-time PUE. It's one of the most well-known and most important metrics in a data center. So now this module can connect to power meters using different protocols such as Modbus. And from there, you're able to calculate the real-time PUE. And as you can see here at the bottom of that graph at the bottom, you're able to compare your total IT power relative to that PUE. And that's a very important aspect as the different sustainability regulations and legislation kick in, requiring data centers to report how much their IT equipment contribute to their overall carbon emissions and PUE.
Hey, can you explain just a little more about the PUE itself, that number? Is that also sort of a number, like there's a standard you would typically use, or you decide what that's going to be? If you can get into a little more detail about that, Rami. I'm not trying to put you on the spot.
No problem. So if you're not using a power meter for DCM to calculate that, then you would have to input that manually. But there's methods that help you to be able to input that. For example, well, first of all, let me back up and say that the DCM collects the real-time power of each device, right? And from there, combining that with the carbon intensity, which is which you can use a reference for the location that the data center is in to calculate that, as well as the that's carbon intensity. And what was the other metric? I'm running a blank here. There was another one that I forgot. Maybe Shuming, you can help me out. What was that other metric? Carbon intensity and...
Sorry.
No problem.
Because I'm reading the Q&A. Can you say it again?
Yeah, no. Thank you for handling the Q&A. I appreciate that. So for the measurement of the PUE depends on the carbon intensity and another variable.
PUE is very easy. The total energy consumption divided by your IT consumption, right? For example, that is the easy one.
But I think the question was about how is it calculated per device? DCM calculates or collects the real-time power of a device, and then it uses the carbon intensity and then another metric to calculate
carbon intensity
the PUE.
is used to calculate the carbon emission data.
Yeah.
PUE is only we collect data from device that is IT device power consumption, and for the total power consumption, we collect data from power meter.
Got it. Yes, I misspoke. I'm sorry, Jason.
No, that's good. No, it's just
thank you.
Share more info on the PUE. Yeah, it's good. Yeah. I'll move on to the next slide.
Okay, so sorry for that faux pas there, but in the end, whatever decisions that you make to improve the carbon emissions and sustainability of your data center, this module allows you to not just be able to create reports to monitor those and share with upper management, but allows you to compare different time periods to see the impact of those changes. So it's not just theoretical or modeling, it's actual. So you can see here at the top, in the last 30 days, my total IT equipment energy was this much, and the carbon emissions was this much. In the last 7 days, assuming that you've taken some actions between those two periods, it's gone down this amount and then further down. So you're really able to see the difference in any changes that you implement, easily and create reports accordingly.
Which is good. It's good to see where you were at and what progress you've made based on the data.
Correct.
So yeah, that's a good thing.
Yeah. Okay. So I think I only had one more slide or two more slides, I should say. So this one is one of the use cases I referred to earlier, which is using the EM module to be able to control the power consumption of servers more specifically. In many cases, servers do not run at their maximum CPU utilization. And for non-CPU bound workloads, this allows you to potentially put a power policy or a power cap on the server level without impacting performance. So you can see here the green line represents the power consumption. And you can see here that after 40 minutes, we've implemented a power policy that caps the power by at least 15%. And in this case, you do not see any impact to the CPU utilization, or in this case, the performance of the system. If we go more aggressive and we do a more aggressive power capping, that's when you start to see a decline in performance. So if you we found that typically that sweet spot is around 15%. But of course, that can vary depending on the workloads and the situation and the server and its architecture and generation and all that. But potentially, you can reduce the energy and the power consumption of every single server in your fleet by 15%, and that can scale significantly and add up to significant power savings. So again, one of the strengths of this module being, able to control and to manage servers on that level. And the second case study here that wanted to mention, which is more of a reliability use case. In many situations, we see per rack, there's two PDUs. One is typically for redundancy. And in several cases, we see that one PDU fails without any alerts or warnings, and the other PDU must support the whole rack for a longer period of time before someone actually notices that overload on one PDU and the lack of redundancy, and fixing that. So with the way DCM works and the ability for you to set, set alerts and subscriptions to those typical events, you can easily get that notification quickly so that you can take action accordingly and either replace that PDU or fix it or something and go back to your original settings and make sure that you're back to full redundancy essentially. So I just wanted to tie this back to some of the reliability features that this module provides. And this is just one of those examples. We felt that this might be an interesting one to portray here to the group, since PDU management is obviously a key aspect of data center management.
Definitely.
Okay. And then this last slide just shows you what I was alluding to, is that there's many use cases of this module. Most of them reflect CapEx or OpEx savings. And if you combine those use cases for a medium-sized data center, that could potentially add up to millions of dollars worth of savings. In this particular case, just using DCM to increase the rack density by just 10%, plus also finding 5% of underutilized servers and increasing the set point temperature by 3 degrees, and performing some power capping or power policies to, like we talked about, to reduce the energy consumption per CPU or per server, that all adds up in this particular environment to $1.5 million of savings annually, potentially.
Right. That's a nice thing to tell your boss, right?
Yep, exactly. All ties back to dollars.
When you say $1 million or $1.5 million, that's a good thing. So,
yep, exactly.
If you have questions, you guys can throw stuff in the Q&A. I'm going to talk about netTerrain and EM and kind of, how they work together. I'm going to get out of these slides here. Actually, I'm going to back up just to one slide. Sorry to jump, but there was a pretty good slide here with respect to this one. So, with respect to the EM the EM itself is pulling data from a lot of different data sources, specifically the devices themselves. I mean, that's kind of its purpose. Its function is to say, hey, let me pull some real-time data or near real-time data from these different devices using different protocols. So there's a lot of data there, and there's a lot of data that you're going to see in the EM itself and manage through the EM. But where does netTerrain kind of fit into this sort of bigger picture here? Well, let me get out of here, and I'm going to get into netTerrain here. Let me refresh my screen here and make sure I'm still logged in. So netTerrain is, again, our network documentation tool. And all we do is we leverage, obviously, the EM and what it's doing as far as its data and bringing that into netTerrain. And I'll kind of show you where that appears. I'm going to give you I'm going to log into my EM here for a second, because I do want to talk about, just to make it clear, from the standpoint of, connecting, how do you get data? What data are you going to see? Where is that kind of thing? Talk a little bit about that. Let me just jump into here and see if I can get logged in. I found a problem earlier, but I think we're good. Okay, great. So a nice dashboard. These dashboards are customizable. This is the latest version. We got this I think about a month ago, maybe. We've been doing a little testing ourselves in-house of the EM. There's been, obviously releases, like all software, you go through release cycles, but the most recent one, as was mentioned, there's some new features and functionality. It's very clean. I've been really enjoying using it. But from the standpoint of, like, you have assets out there you want to monitor and manage, and it might just be PDUs, it might be the servers also, there might be a whole collection of things that you want to do. One of the things that's really nice about the EM is the discovery tasks that you set up. There are different options and protocols that you can choose from. I mean, SNMP is always the big dog. That's the one that's been around forever, and that's what most people use. And a lot of times that's what we're going to use with your certainly things like your PDUs. But from the standpoint of, like, servers, IPMI is usually pretty popular as far as grabbing data. And then there's other protocols depending on the device types and things that you're going to use. But what's nice is you go out and do that discovery, finds all this information, and then you can sort of sort that into your hierarchies of the tool. And once you do that, then you can start to see data that you're collecting over time, for instance, for things like power or even temperature, like in the bottom right. So what we do is we leverage that information, that discovery of data that you're doing. So one, to help with automation, and two, so you're not necessarily doing some redundancy of your discovery or tasks. So we're, again, hierarchical tool where you can kind of drill your way down into more and more detail. But as was alluded to, with respect to rack and stack stuff, here's kind of typical where you have a building and you've got your data center. And in our case, you can show it, if it's on a certain floor, you can show where the data center is and then all the equipment and those types of things. With the EM, we can take advantage of its discovery and basically use that to help build out your cabinets, but also then start to feed data into it, but then have them talk to each other, where I can go from basically one system to the other or back, kind of thing. So with respect to netTerrain, visually, I can show you a cabinet with a lot of detail. So I can double click and drill down. This is how we represent cabinets. Basically, you see your data center kind of from a top-down view, so you can formally see your data center, let's say on a data center floor plan like I have here. In fact, if I turn that off, you would see just what we refer to as netTerrain objects. But here you could see the background, and then I've positioned my cabinets. And you'll see the cabinets are different colors, and those colors are being driven by things like power and rack utilization, and even weight, for that matter. Obviously, with respect to EM, power's, sort of the big dog. You're going to be taking data and rolling that up and using some of that real-time power data if you want to. In my case, I'm using some manufacturer spec to roll that up, but I can do that from the EM and get real-time data, and some of the data that's in here I'm getting down to the device level itself. But, part of this is to help, obviously, in an automation, to automatically help you bring data across and do your network documentation. So, because I don't want to have to necessarily do one thing in one tool and then have to redo it again in another tool, right? I want the tools to talk together, and that's what we do. And what we do is we leverage the EM APIs, the REST APIs to help us pull data and so on, but also the visualization. We're very much a visualization tool from the standpoint of I can see the devices, what they look like in the rack and things like that. I can also do what's called a visual override, where if I exceed a threshold for data, like in the case of power or something, I can change the appearance of the object and I can have it trigger alerts. I can do that in EM also, and that's a lot of times that's where I'm going to start that process. I'm going to really trigger my alerts in that from that standpoint. But I can leverage the data in netTerrain and visualize my cabinets and my PDUs. The other thing in netTerrain, because in EM you can build racks, things like that. Obviously, we build a rack. It's kind of manufacturing. You kind of see what it looks like, but also we do connectivity. That's a big thing for us, is the connections, device to device, whether it's power or data or outside plant where you're doing fiber cables and strands and things like that. So it's nice to be able to, you set up your EM, you capture all this wonderful power data, set your alerts, set your caps and other things, and then use that to help with your network documentation, where you're documenting all these things. Where does it live? Where is it in the rack? How are these things all connected together? So it gives you a big picture overall of your network and your network documentation project, but also you, of course, are getting into alerting and monitoring and other things. But so, both tools, they're going to bring a lot to the network documentation that you might be doing in-house. And again, we're trying to help you from the standpoint of the automation side. Let's do a discovery, let's find the information, and then use that information to hopefully save you money and all that good stuff. So, but anyway, if there's any questions, please post those. That's all I really wanted to talk about. If you guys need a broader demo or test things out, whatever the case may be, by all means, let us know. With that said, let me jump back to our PowerPoint. Let me go down to the bottom. All right, let me just see if there's any questions. I want to make sure I answer any questions that are out there. And give me 1 second. I'm going to stop my share just temporarily. It's a little easier for me to, be able to import rack temperature in netTerrain and set the color option off the temperature. The answer is yes to that. So we can, again, we use those REST APIs to pull that data across. Now, that data could be coming in individually, certainly the PDUs. It could come from, of course, individual devices in the rack as well, or all of the above, if needed. So, yep. Don't see any other questions. Let me check and make sure I didn't miss anything on the other side of the house here.
Jason, can I ask you one question? Can all